Hello and welcome. I'm Bill Wake. We're here working on a Tune Similarity project, and we're in a little bit of a tight place. I've got the look of something that's a pipeline, so it gets some input and it transforms it and makes a report and prints the report, but it's not really being done as a pipeline. Excuse me. It's drawn that way, but inside it's just one of those stages is privileged and just runs the whole loop itself or the whole pipeline itself, and there's no true pipeline involved. And we started doing some work to make a real pipeline, but it got balled up in a couple places, and I don't know if I can describe them well enough. Let's see. It's well, we have this notion of source. Okay. Excuse me. We have transforms with inputs and outputs, but when we try and use it, it tells us, "Oh, you can't do that. You've got to, I forget the phrasing, but consider a generic constraint type or something." And I'm not quite sure what they're saying there, but I think I might know. I don't know if it's a solution or not, but I think I can say what the problem is. So the deal is we're using two types here, and you might like to pass transforms in, like put them in an array and use them. That's what we're trying to do for our pipeline. But it's like, oh, if it were inheritance, you could do it. But inheritance isn't going to fit very well. Kent Beck says inheritance is a card you can only play once, at least in Swift and Smalltalk and Java. You can have protocols, but not multiple parents in a subtype sense. And this is really kind of a cross product, right? It's the input and the output. They're two separate types. And there's kind of not a good way to represent that in the way we're doing it. My analogy, I don't know, it's overused, but I think of cars, and I could have engines, gas engines, diesel engines, electric motors, hybrids. That's kind of one dimension. And then I could also have maybe a dimension for transmission is a manual or automatic. And then I don't know if fuel is a separate dimension or not, but it corresponds to the engine type or motor type. But for some purposes, you'd like your classes to be separated by their transmission, manual or automatic, and some purposes you'd like to know their engine, diesel or gas or whatever. And you can't put both those in a hierarchy. If you try and do a combination thing, then you've got like two combinations of transmissions and four combinations of engines, and maybe three or four possible, it could be, if it's more transportation, it could be a flying car or a floating car or a combination or something, like all these possibilities. And you start multiplying all the possible subclasses and you go like, oh, there's got to be a better way. And usually there's a way, but it's a challenge. I tried explaining this. I get together with some friends on Tuesday nights and trying to explain it here. Yeah, so my input types could be text or tunes. My outputs could be text or tunes. There's actually outputs can also be measure transformations in our system. And one suggestion I got was like, can you make these things? Can you constrain these types? And Stream was his name. I'm not sure I'd use that name, but that's a thought that maybe we can force these to be a particular type. I don't know what that is. We have a packet type. Let's see. Packet. Somewhere. Type alias. Okay. Yeah, so I was trying to make I was going down the path of saying there's a packet type and it's going to hold the types that go through. But then you realize like, oh, wait a minute. All these types that could happen, like you could have the tunes type, you could have a measure transformation, like our quantizer does. You could have text coming out. You could have a title coming out. You could have this, that, and the other thing. And if I add more types, I'm going to extend this type, and it's going to be this big giant vector of like all these possible types, like that just seems like a bad path too. Even if I put it in a class, I'm still not happy with it. So all of a sudden everybody has to be prepared to deal with every combination of input and output types. It just feels like a bad direction. So what I thought I'd do, and I started doing off camera, is a playground and see if I can simplify our problem enough that we can solve it in the playground and then take that learning back. Okay. The other thing I did was, let's see if I can find them. WWDC 2022. There's existential. That was one search. Okay, sessions will get it. Let's find opaque. Right, yeah, so this one and this one. Okay, so they say do this one first. All right, and these are two talks from the last WWDC and WWDC, if I want to be in the cool crowd, I guess. But anyway, they describe some what they call opaque types and how to make generics work with them. And then this one describes what they call existential types. I don't know if we need that complexity, but we're going to try. We'll see what happens. Okay. And I think I'll try and explain that a little bit. So to do that, let's see our content view, because what's going on is this notion of opaque types is captured by this keyword sum. And so when you create a page, a view in Swift UI, you have all these operations, scroll view and stack and text, and we made our own custom ones, quantizer, setting view, and so on, spacer, and so on. Well, the type of this thing, we're saying we're producing some view, but the real type is a scroll view of a list of VStack, which is a list of text and text input view and quantizer setting view and so on, followed by a spacer at that one, and then that's it. And so the type is this huge complex thing. I don't know if it expands these types, but if it does, it's even bigger. It's every little widget on the screen in a big tree, and nobody wants to talk about the type that way. Like if I added a text here, ta-da. Okay, I've just changed the type of my result because it used to be a VStack starting with text and then text input view. Now it's a VStack of text input view. It's a different type, but because I said some view, I'm saying if you're the receiver of this, just treat it like a view. You don't really care that it's a scroll view of a VStack of etc. Okay, and this is called an opaque type, and it's triggered by this sum keyword. Now, it kind of there's a difference between kind of what you produce and what you receive. So if you're in a if you're receiving it as a parameter, which we are in one place, let's see, I guess if we go to quantizer setting view, okay, we passed one of these in as an argument to top line. All right. So here's this horrible type, HStack of toggle of HStack of this, that, and the other. And every one of these views for us has a different version of that. So when they come into us, our top line method or class struct, okay, it takes an argument. The view coming in, it has that complex type, but we don't care. The result of it is some view, and we're just using it. We just put it in there, okay? And we don't have to worry about what's your real type. We just worry about like you're a view. Okay, I'll use you like a view, and so it gives you this kind of it's not really, I don't know how I want to describe it. It's kind of a wrapper, or it's a simplification to say just pretend it's a view. Don't get into the complexity of it. But the compiler keeps track of the complexity, and it can do stuff with it it can see what's inside and require things to match and things like that. It still knows it. So the compiler tracks that complex type, but when you're using it, you just pretend it's a simple type. And inheritance isn't a good fit for this. So they've introduced this new concept of opaqueness. Okay, so coming in, you just use it. Going out, you build something that's of a complex type, but whoever gets it from you just gets the simplified view. Okay, now the next one is any. And I'm probably going to mess up the explanation there, but the situation is sometimes you want to put, like, you want to make a list of incompatible types. Now, if you make a list of compatible types, they've got a common superclass. Everything's fine. Put them in your list and, just call the superclasses methods, no private methods on the individuals. And for the most part, you don't need to do any casting or anything. You just take them off the list and use them. But when you get to structs, they don't, they're not classes in the sense of a normal class where you have a supertype and all that. They implement protocols, but they don't inherit per se. And so you can't put them in a list in the same way. If they were all the same type, I could put a bunch of top lines in maybe, or a bunch of H stacks. Well, maybe a bunch of texts. Okay. And they would all be compatible. But if I want to say, I just want to keep a list of them. They're all miscellaneous types. I don't know what they are. I just know, I know their views, but I don't know anything else about them. You can use this any keyword instead of some, and it says they're basically it wraps them in a box is how they describe it. So I think of like a shipping container, going on a ship from China. This one's full of bicycles. This one's full of lawn darts. This one's full of little plastic toys. We don't have to care what's inside. We just stick the container on the ship and are done with it. And it's kind of the same thing here. It gets wrapped. We don't care that it's a Z stack or an H stack or, a million other things. And then we can do some very generic things with it. Now, what the wall we hit was we can't call our doit function because it just doesn't have enough information. So there seems to be a way around that based on these talks I looked at. And we're going to see if I can kind of replicate our situation in the playground and go from there. Okay, so I made up 3 functions. String length is a transform from string to int, just counts them. Squares an int to int, squares them. And then toString converts int to string. So that's kind of like our analogy of all the different pipelines. Okay, and I think I can still do this. Okay, so I can take an input. Well, I'll move that around. Let's just do ABC directly. Okay, so I'm putting in a string to a string length struct transform, and I guess it's a class here, but it could be a struct. Putting a string length in, and x1 produces the length of the string, which is 3. And we take that 3 and we pass it to square, which produces 9 for x2. We pass the 9, and we should get a string 9 back here. Let's run it to here. Okay, whoops. Icon name. String length does not conform to transform. Where's transform? Well, let's put it down here. Input, output, do it. Okay, let's see if that helps any. I had this working at some point. I guess packets down here too. I moved stuff down to try and match it up to what the talk showed me. All right. Let's put packet. I thought this would be the easy part. Oh. Type string length does not conform to transform. Possibly intended to match string length input does not conform. Oh. Let's take this out. We're simplifying, so let's just simplify a little more. Okay, so we're going to ignore packet. I'm just saying transform takes an input to an output via the doIt function. Probably transform would be a better name. And I think this should conform now. Probably stuff further down will break. Yeah, let's just grab all this and comment it out for now. Okay. Yeah, there it is. Just 81. All right, something's wrong. X3, oh, square. That should be twoster. Okay, so it hit this transformation. Okay, so what that tells me is that if I've got these things statically, I can do it. You know, I can feed one to the other and make the transform go. The problem is I would like to do something like this. I don't know if this will compile. Okay, so I want to have a pipeline. I'm not sure how to make current be anything. Well, okay. What I'm trying to do is create a pipe, and let's take this out for a moment. All right, and it's a bunch of transforms like string length, square, and twoster. Okay, so we mentioned before they're incompatible types. They're generics that are expanded to, you know, this one's string to int, int to int, and int to string. Okay, must be written as any transform. Okay, well, we'll do it since you say. And that's compatible with what we know of any. It's saying you want to put incompatible types together, then you got to do this. Now here's where we're getting stuck. Okay, I think both of these. All right, like somehow I want to say my input. Yeah, I don't know what to call it. It's not a packet. I mean, I can do this. That's fine. You know, I mean, I'm just saying there's a current, but I want to update current with the result of each type. And so I get lost there. Current. Okay. He's, yeah. Okay. Here it is. Remember, do it cannot be used on any transform. Can you consider a generic constraint instead? So current is, it's a string. Well, the result of the first one of these, string length, is now an int. So current can't be an int at this point. So like, how do I reuse that variable? When you want to say something's a very generic type, there is another type that's kind of it's almost like a void star in C or C++ that lets you match any type, and then you got to do downcast to get to it. I'm kind of trying to avoid that. I don't know. Okay, so I think you're current to where I'm stuck. I want to do this where I create a pipeline, and then I run through them and apply the current function to each one and build up the next value. But I can't do that because the types are incompatible across each one. They don't know what to say the output type is. Okay, so yeah, I guess basically, as far as we're concerned, the result of any transform is going to be some sort of any that's a generic, not even generic, I don't know the right word. I think it is void star, like I said, so it points to anything, and we can't assign an anything to a string. Now, I don't know if I can do this. I haven't tried this. What if I said it's going to be an any, and you just deal with it? Okay. And I think we're still going to get this, yeah. Consider a generic constraint instead. Okay. Let's look up that and see if those words trigger anything. I think this is why we're introducing packet above. Okay, generic types. And this is a decent side. Okay, let's look for constraint. Okay, this is a fairly old article. Okay. Yeah, we can restrict the inner types. Okay, so if we're extending collection, but we're only going to extend collections that contain strings. And that's fine. Use closure types and constraints. Okay. Okay, type constraints and generics. Okay, so we protocol with a model. That's right. Yeah, we'd like to be able to make queries different. Okay. All right, so here we've assumed the query type is string. Here we haven't constrained it. We've just said it's any kind of query. And the collection, rather than an array of model, well, it's sort of like any collection, so we don't have to restrict ourselves to array, which is nice. But we want to make sure the collection contains models. Okay, so that's a nice little generalization, and we still have model. Okay, we can implement model managers. Okay, query is an enum. Then we have models matching this to user. Okay. Or you can make a dictionary. Okay. Well, that's interesting. I don't know if it quite answers. Okay. This is 7 years old. I'm sure it's a little out of date. Okay, container with elements. Container. All right, this is all great, but solutions make the functions generic and restrict the parameters to the protocol in question. That's the kind of thing I think we need to do. Perhaps. Okay. 2021. This is probably more recent enough to matter. Okay, so extension where. Okay, we can put these on those associated types. I don't think they're seeing that here, but that is true. All right. So I'm going to set this one aside for now. And I think we'll take a look at what this is the one. Well, this animal thing is their example in that video I mentioned, or those videos. Okay, so you have animals that eat food, and then somebody is a food provider. I got a feed all and a feed. Okay, so I'll just move this up out of the way. Okay, so animals eat food. They're food providers that given an animal for that animal, they provide its food. Okay, and then you can write a feed all method that takes a list of animals and a food provider, and each one, and feed each animal. And feed is down here. Okay, so it runs through the list of animals and calls feed on them with the provider that we passed in. And feed, let's see. Feed gets food for animal. Do we have that in our thing? Okay. Yeah, gets the food and lets the animal eat the food. Okay. Now, okay, and this is kind of where I left off. So, writing a food provider. I don't know if I can. Yeah, well, the thing going on here is you got an animal T, and then it asks it for T.food. So the animal had to provide a type. So kind of the type, the animal's, this T is an animal. I don't know. I'm going to rename that A just to kind of keep us. Probably should have done that automatically. Okay, so food provider, if you say get a food for a generic type animal, and we're going to produce A.food where A is an animal. And you probably can put that in here, but it's okay. It constrains that type across here. It's got to be an animal, which means we know it knows its own food. And then we're going to do something to get the food for that animal. And that's kind of where I left off. So let's see. I've got a bunch of screenshots. Okay, let's start back here. Okay, so we've got protocol, animal, food, a farm. Okay, so feeding an animal, we're going to grow the crop, harvest it, and then let the animal eat it. Okay, that's a little more complicated than I want. All right, so take a particular animal, cow, it eats hay. Okay, so his food type is hay, gets implicitly kind of recognized. And hay, you can grow it from alfalfa, and if you harvest alfalfa, you get hay. Okay, and so hay.grow, harvest it, and cow eat it. All right. It's my true hope that this helps us in the end. I don't know if it will. All right, similarly, you got chickens, they eat scratch. Scratch comes from millet. Whole structure is the exact same. It's just basically duplicated across there. A better person would organize this into a folder and dealt with it that way. Okay, here's animal feed. It's got to have a crop type, which is a crop, and the crop has an animal feed and harvest. Okay, this is going to get more complicated than I think we need for our situation, so I don't know. We'll see. But same thing. It to feed the animal, you grow the stuff, you harvest it, and then you feed the harvested food. Okay, can I skip? Okay, this is the stuff I want to skip. But what they're getting to is you can constrain these types in a way that they all work compatibly, so that the food goes back to the crop and vice versa, and not going on an infinite loop. Okay, I think that's more of the same. Yeah, so by constraining these types, the associated type, animal feed, where, well, we want to make sure that it's a feed, the feed type's crop type is the same as our crop. Okay, so we're trying to make sure that the two steps of that, we don't want to go down an infinite regress where we're, finding a feed type which gets a crop, which gets a feed, which gets a crop kind of thing. Okay, but I don't think that's our situation. No, that's a poor shot. Animal hungry, feed it. Animal feed. Okay, we're still on that example. This one. Oops. I really don't care about that one. Okay. That's all constrained. Well, these are the generic constraints they're talking about. So associated type implements a type, and then here's a relationship of it to another type. I don't know if we can get that out of our situation or not. Whoops. The last real one. Okay, no, that's not helpful. Okay, so I don't know. Preview. Okay. The other thing I saw in that talk was something on the lines. It's like this thing. It's going out to this external thing that's all constrained for us. And it's sort of moving from an any type to a specific type, and then it can know the type from that. Okay. Because we said the food provider gets the type that the animal wants, t.food. Okay, so I think that's the kind of thing we're going to have to do. I don't know if we can. Okay, so again, I think the heart of this for us is this pipeline thing. This much is good. I mean, this reflects what I want to do. Because for us, we want to put, quantizer and report and so on. Okay. Now, how do I reduce it? Well, this is where packet came in. Okay, we said, what if there was a common type? And inputs promise to be packets and outputs promise to be packets. And we're going to make extensions. We're going to say strings are packets. We don't have to say anything about it. It's sometimes they call it a marker interface, marker type. String and int. We're working with both those. So let's say those are both packets. I don't think that's enough, but we'll see. Okay, so now we're promising that the types we pass in for inputs and outputs will be packets, and we've made sure we use types that are packets. Okay, and that seems like it's complaint free so far. Okay, and I guess that gets us down to here, and maybe we'll see pipe. Okay. Excuse me 1 sec. Okay, so we haven't broken anything. That's promising. All right, is that constrained enough? We're saying you know how to be a packet. Now that gives us a type for this current, right? We could say current is a packet. I think that should work. Okay, because int or string should be fine. Let's try another one. Var int is a packet equals 14. Those should be fine. We don't really care about this one. Okay, but either type can be in a packet. Now, this bit of trickiness. Okay, if I pipe for each, okay, they're using a generic constraint. Well, what's the constraint we're putting? It must be on transform, right? Where... What is the constraint? I mean, it's an output, input's a packet. I mean, what I really want it to be is the output type. It has no relation to the input type. That's not the problem. The problem is when I go between pipeline steps or stages, those those need to be related. So if I connect one that produces an int, I got to connect it to one that accepts an int. And I don't see how to constrain that across these things. Okay, so what I saw them do, it's what was it? So I think it's kind of like this feed thing. Let's copy this up there. Well, it's feed and it's food provider. Let's get that one first. We're just trying to use these for inspiration. Okay. I guess I'm gonna. What was the error there? Yeah. Okay. Feed in scope. Where's feed? Oh, I got feed all but not feed. Okay. Now this is the subtle step that they get through. I mean, there's something about, like, this is not directly using the type on the object. So food provider promises to get the food for an animal. Okay, so the food for an animal. Okay, I think that kind of corresponds to our input type, maybe. And that's that constrained type there that produces t dot food, uses the type from the animal. Okay. Like somehow, in 64 it calls feed, and that feed is set up to get the food. Like, it's only going to get the food that the animal will accept. Okay, it won't try and feed chicken scratch to a cow. Okay, so with us, we want to do that on the input. Let's try a protocol. Input provider. Get input from animal. I think it's from a transform. And it's for transformer type T, and it's going to produce T dot input. I'm gonna try and do both. Let's do a get output. And this is maybe a transform IO. All right. Now to feed, well, let's say transform T of transform given a transform of type T and a IO of transform IO. That's by analogy to this. Get input for transform. Output equals transform dot do it of input. Do I need the output? Okay. That corresponds to the feed function. Then feed all is my loop. Okay. Provider, I guess that's the transform IO. Given those, can I do it? Okay, well, they run through animals for each. We're going to do pipe for each. Well, transform, let's call this pipe. Pipeline. They're calling feed. I don't think I get to do that. Well, transform corresponds to feed is void. I think it has to produce. Where O equals T dot type dot, no, T dot transform. I should be able to say T dot output, I think. And then I'm going to return it. Cannot find O. Output to return type O. What's the problem up here? O constrained to a non-protocol, non-class type. O is a packet? It doesn't seem specific enough to me. Like somehow, yeah. T dot output to return type O. Maybe this is just T dot output, and I don't need O. Okay, so given a transform, pass in the type and a transform IO, and you get an output. Okay. Okay, we got pipeline for each. Yep. All right, we want to call feed which is our transform. And $0 is the pipeline. The transform, the stage is the pipeline. And then we need the IO. Okay. Well, I think that's going to be acceptable type-wise. Oh, yeah, that's the tricky part. Right. So, okay. I mean, I think we're closing in. I don't know if we can cross over. This is producing, transform of this produces an output, which is of the type specified by the transform. But now when I assign it, let result equals that. I don't know. The type is probably going to be any, I think. It's packet. Well, maybe we can make this work. Let packet equal well, I think we're going to have to say input. And we're going to have to be given a starting input of type packet. Okay. So we start with a packet. Okay, now I want to say packet. Oh no. I ought to get input. I don't know where I have a transform IO. What next? Input equal IO dot input. Get input of $0, the transform. We're getting his input. I don't know. It feels like I should be doing that down here. Transform T. Maybe this needs the input too. I just don't know. If it gets transform, like somebody must give it the input, right? Input of packet. Okay, so I don't know what this thing's doing for us. Okay, but I think that is kind of what we want to happen. Cannot convert packet constructor t.input. Do I say where packet equals t.input? Sure. Still heavy. Generic signature requires t.input to be any packet, and t.input goes to t.output. Well, oh, no, this can't be. Maybe this goes at the end. No type for input can satisfy t equals any packet, and t input is packet. Okay, that's a problem. Oh. I'm not seeing a way out. I really wish I had a Swift type expert on call. But I don't know what you can do, right? Because the real constraint is item sub I in the pipeline and item sub I plus 1. The output of the first has to match the input of the second. And we have to be able to pass that type across them. They're just packets, but we don't. Okay, can I? T of transform. Okay. I mean, I feel like there's something I'm not quite getting. I don't have a great plan B. My plan B is just to put everything in one big class and say, that's the possible transformation stuff. And if you want more, you got to add to it. I mean, at some point, like we know there's input text. We know there's, well, if you go right to the report, there's output text and a title. You might be able to fold those two texts together. Although, actually, you probably don't want to. Okay, so output text and title. Quantizer gives us a measure-to-measure transformation. The tool we don't have to convert everything to the same octave can be done measure-to-measure. So you have to be able to compose measure-to-measures. That's fine. Okay. Yeah, I just don't think we can do it. Input is packet, where packet is t.input. Can I just say t.input? Drop the where clause. Sometimes Apple has these help sessions. Maybe I should see if I can get one of those sometime. Okay, what do we got here? Well, that's a little better. Okay, so transform function, given a transform and a transform IO, which I don't think we care about since we don't seem to use it anymore, and an input of type input produces an output of type output. That seems axiomatic. All right, let's take the IO out of there. Maybe he's not needed. Well, let's leave it for now, I guess. Okay, so transform all. I'm going to take the input. Okay, transform output. Last call is next input. Okay, that's true. Okay. why are we getting it from there? Any transform cannot convert to transform. That's kind of the problem, yeah. Any transform, I guess that's, okay, yeah, that's $0. Let's say my transform in okay, this should be any transform. No. Why are you an error type? Because you're an error. Okay, let's take this out a moment. Is a transform. Why is he not an any transform? Result is transform. Okay, that's this transform, right? Yes. Okay. Make sure we didn't get one too many. Okay. Cannot conform to transform. Is result transform? I think it's going to be error. Yeah. Result of this is an output. Next input should produce an output. Okay. I mean, it's like, I think I've watched that presentation like 3 times, and this is the first time I felt close to getting it. But clearly, if there's something in here, I'm not getting the result. And this is really a reduce. I should say that. Like we're taking an initial value, and then we're applying successive things in the array. Each one produces a result from the next one, and in the end, we want the last result to come out. Maybe I should write this the way I want it to be, and go from there. Result equals input. Next input. I'll make this a var. I think I'll get 2 complaints now. Just one. Next input is given the pipeline. I don't know. That input doesn't seem like it's getting the input, does it? How would I get input? Like, who defines this? We don't. Well, I guess this IO does, but I really don't even want that. I really want result. Okay, so I want you to take the previous result. Let's take this out. Whatever this result is from the previous transform, feed it into the next transform, get a new result, and then in the end, return result. And this is, I don't know. It's like, it's the transform of the last, well, it's a packet. We know that. Okay. This is still the heart of the problem. Cannot convert any transform to a transform. Okay. Well, good experiment. I will have to make. Okay, I'm going to add that to my little to-do list here. Sorry. Remind me to schedule a call with Apple to look at this pipeline type problem.
Okay, added.
All right, we'll see. I'm going to comment this out just so I don't leave a playground that's failing. But I think that was the only error. No. Yep. Okay. Well, what I'm left with is I think I need to make this superseding type that says transform everything to everything, and if you don't know what to do, just copy it through. Reasonable enough, I guess. But in a way, it's reasonable. I mean, if you get the tunes coming in, even if you want to, like, if you transform a tunes to, by saying you should add this measure transformer to it, that kind of says to anybody who's going to get the notes, they have to do it. I don't know. Let's run it and see what I say. Makes sense. The occasional glimmer of sense. Okay, so this takes this input here. That's not part of the pipeline. It just produces the first, it's a source. It produces a tunes object. Okay, this should take the tunes and add, it really just adds a measure transformation. It doesn't actually transform them. We could define it to work that way, and then it would convert tunes to a new tunes, which is kind of conceptually what it does. It's just that I kind of didn't want the overhead of, like, if I had a bunch of these transforms stacked up, like rewrite tunes with this, rewrite tunes with that, rewrite tunes with the other, keeping to rewrite tunes all the time. Instead, I could just say, like, stack up these filters or maps, and when you actually want to enumerate the notes, then run it through this. Run through them and apply this change thing to it. Maybe I'm worrying about stuff before I have to. I don't know, but we'll see. Okay, and so instead of being specific, I'm going to build a type that has all the stuff I want to pass through for any transformation, and we'll go from there. Maybe the measure transformation, I should swap it around, but I don't know. Some of these files are pretty big. Maybe it's not enough to worry about. I mean, text processing is so fast on a modern computer. All right. Well, we're due for a break, so let's take a break. We'll switch gears when we get back. Define that. Define that packet type to contain everything we want to transform, and go ahead and start building this pipeline a little bit. I think we can make a pipeline that works with that, because then everybody is, give me a packet, I'll turn it into a packet. Input is packet, output is packet, and that's the way it goes. And I don't know if there's a better name for that. It's like total state or something. Really, it's a state vector, but I don't know. Packet works for me. All right, 3 or 4 minutes, and we'll come back and give that a go. All right, welcome back. Okay, so let's just close some stuff. I think I'm going to close everything, and we're going to start with packet. Okay, so packet, I think, should get its own file. We're growing it at this point. New file. I'm open to a better word than packet, but I don't have one. Okay, the object of a transformation is the something. Okay, and Parsons code report, add packet. I guess I didn't run all tests. Let's do that. And oddly, the pipeline, is it in source control? I don't know how to tell here. Okay. Right, everybody's green. Good. Now, packet. Well, let's see. Transform. Okay, I think this is all commentary. I don't think I need this anymore. We're just saying packet to packet. Okay, so a transform has a name and an icon, and it has a function that does the transformation it wants. All right, that seems cool. Nobody should mind that. Oh, maybe somebody does. Yeah, he's got to update some types. Oh, we're going to have to input his packet. This has to be a packet. Let's see, packet is measure to measure. Oh, I'm going to make it bigger. We'll fix this type in a minute here. Let's just get this together. Tunes measure. Well, it's transform string. Tunes quantize map and ignored. And then we return tunes quantize map and the report. I think that's right. Oh, and a parent. We will deal with that. Okay, anybody else complaining? I thought there would be one. Maybe we've only started one transformation. Okay. Let's. Oh, I guess I did that. Okay. Now. Let's see who. Does anybody call this? Somebody must, because they would get the icon from there, but who else? We build one here. We create it here, and we hold it here. Oh, well, that almost sounds like we're not even using it for the icon view. Let's see, where's your icon? Let's do it. Top line source is a transform. Well, I don't think he has to be any transform. Can we do that? I don't think we'll need the word any the way we're doing things now. Okay. Okay. Now, this parsons code view. See this button, do it here? Like this stuff is, it belongs to that first stage, the text input stage that we have right now. That should create the pipeline. Um, I don't know when to pull this stuff in. Where somebody's got the pipeline. Where did that thing go? This is just one stage. Okay. How do you actually do the report? Well, when you call do it on my packet, you give me a packet called do it. I'll give you back a packet that contains the report stuff. I think that we should be able to call that. Excuse me. I think we're going to switch this type over to a struct first, and then make you explicitly say what you're returning back. Yeah. Okay. How can we do that in here? We have the transform. We can call do it, right? So here we call parsons code report dot this dot that. Okay, but we could say output equals source dot do it of tunes. Let's make sure. Well, that's a packet. Okay, so it's the tunes quantize map and empty text. We don't have any text going in. And do it just takes the one argument, right? So yeah, so we pass tunes quantize map and text we're going to ignore, and we produce this. Okay, so that do it. I believe that does the job. Oh, almost. Can assign. Okay. Nothing output. Let's take this one out. Output. Okay. If this works, it should work. We'll have to run it to see. This is all UI code. I want to get this moved over into the system, but let's find our no scaling. Throw the big one at it first. Okay, generates the report. No, we lost our scroll view setting. I don't know why. Okay, but it's doing it. That looks like the report we've been getting. Okay. So that transformation is doing the job. That's a big step. Okay. Parsons code view. Now it's doing the transformation. All right. And I think this is probably the moment to switch packet. Okay, so instead of that, let's make packet a struct packet. Let tunes be tunes. Let transform of, well, that ought to have a name. Okay, let's give it one for now, and then we'll figure out where it belongs. Type alias measure transform equals that. This is now a measure transform, and a type alias is kind of, it's like a nickname for it. So anybody can use either the original form or the nickname. we could turn it into a type, but we haven't. Okay. And I think maybe that's okay. All right, so a transform, a measure, and then a output of type string. Okay. And then, yeah. All right, now there's some people should break, and we can make them. Okay. We'll let the packet equal this result, and then say output equals packet dot output. Okay. And this is packet. And we're going to add is that what we call it? Measure map transform. Really, it's measure transform. We'll get to you in a minute. Measure transform. Okay, that should become okay. Yep. And then this one. Rename this to packet. And this is packet. Measure map. And the output. Okay, yeah, we don't care what it was, we just care what it is. Tunes. Don't need that anymore. Okay, increment label have tunes. Measure map output expected tune measure transform. Okay. Okay. How are we doing? All right, so we've done the convert to use new packet struct. Now, would we be better off? Yeah, unfortunately, we can't default it to the previous one. That's too bad. But maybe we could get a field. Let's refactor this a little. I don't think these are expensive to copy, really. So let's. Okay, we'll take that one. And then let's make another one Well, it's going to look a lot like it. Okay, this one's going to take one. We won't make you name that one. Tunes is optional tunes, optional transform, and optional string. Okay, so if tunes not equal nil, then tunes, else packet dot tunes. Measure transform, if it's not nil, then measure transform, else packet dot measure transform, and then same thing here. Okay. I always forget these escapings. Do I have to put one here too, right? I don't understand. I just don't get it. I think it's probably just as much an escaping. No? Oh, okay. All right. So what we're saying is, given an old packet, you can turn it into a new one by specifying one of the fields that you want to change. Okay. Let's use that here. So this is packet with output. We don't need tunes. We can default them. Oh, we've got to default them first. Okay. Packet measure transform equals nil. All right. So I think that will look better. I don't like all the fields in this class, but I think this will help. Most of the time, you just care about the ones you care about, and that'll do it. All right. Should run. Oops, there's still 2 errors. Oh, you haven't caught up. Okay, there we go. All right, so give packet optional arguments so it can update from the previous one. Okay. And I'm going to rename this function to transform. Okay. Give me a name, an icon name, a transformation function, and I'm good. All right. Should be trivial. Okay, and this is transform. All right, we have not dealt with source and sink. I don't think we're gonna care in the end. And in a way, that's right, because I could envision a report that maybe stacking up a couple reports. I don't know. Okay, let's go to parsons code views thing here. All right, the next thing I want to do is, notice I have title. That is setting this binding here, but I think it can become part of our packet. Okay, so the title is kind of the report title. And it's a string, likely to be a small string. And we'll just add it in. And add it down here. I don't think I'm more moving things around than creating new features, so I think I'll just keep doing what I'm doing here. All right, and same deal here. Okay, and then some people should be missing it. Yep. Not quite that way. Okay, title here. I guess we don't provide it. That's the job of the transform. Okay, and then we want to say title equals packet.title, and this should go over to our Parsons code report transform. Okay, output. Well, title is Parsons code report. Okay, let's. Okay, and if we, whoops, run that. Okay, so we should see the title still on our report. Okay, I'll just make up one, X1, T test, key G, ABC. All right, Parsons code. Okay, do we commit that? Yeah. Make title part of the packet. And we may be done for now. That may be all we have. Okay. Now, this quantized map. I really want this to come from somebody else. I really want this to be done by somebody else. So the real thing I think we want to do is I want to have an array that's a pipeline, and the stuff that's drawn on the string on the screen comes from those transforms tell us enough information to do the stuff. And I think we are these colors are kind of a factor of, are you a sink or a source or a transform or a report? We kind of have four things. I think we want to make that's a characteristic of the transform. So a sink sort of says, well, I'm not planning to produce anything for you, so don't rely on my output. And a source says, I don't need your input. I'll just produce what I want. I think something that's conceptually a source, like I wanted to draw them differently too, and we screwed around with that and didn't make any progress. But I do want to draw them differently and make a visual distinction between the different kinds as well as the color distinction. So how do I get that input going? And then the other thing is I want the pieces to come from the individual stuff. So I want to talk to the pipeline and say, hey, input, give me your stuff. And he comes back with the tune. Oh, and the errors. That's another thing that comes back. All right, let's add those before we go further. Errors is array of ABC parser. Error, parse error. Okay, goes in packet. Okay, and same pattern here. You can see why I thought this thing was growing kind of big and kind of wanted to avoid it, but I guess I can paste that still. ABC optional equals nil. Okay. Okay. Errors, bang. Okay. Now there's going to be a bunch of people. This is the downside of this. Like all these places that touch this need errors in their call. Okay. But I think we can use our other packet thing, right? Let's make our packet. This is more like a result. Okay. And the packet, well, I can put it way up top. This one we have to do. Tunes is can I do that? Wait, no. I don't want packet. I just want tunes. I want this one. Okay, spare me. Okay, packet. This one. Okay. This is tunes. This is well, we had something for that. None. This may be the wrong place for it, but okay. So tunes. Measure transform. And I don't know if I'm. I think it may be helpful to put these markers in. Errors. Empty. no tunes, unknown, none. Okay, and then this. The transform is well, it's really packet with tunes, measure, transform, quantize, map, title. Yeah. I don't think we don't care about these. They're outputs, not inputs. Okay, so take the packet with the tunes and the measure transform and whatever default errors and all that it has. Okay, do we have everybody together? All right, let's run this. And let's run it this way. Key T test, key E, CB, whatever. Okay. Okay, it's got the title. There's no errors. Let's put some errors in. Leave out the title as an error. Okay. Good. Yeah. Okay. And so this should be do we add errors? Well, we added errors to the packet, but we also changed the parse code view. Okay. Okay. Cancel you. All right. That's kind of an initial packet. That seems All right. I kind of want to. Okay, this seems good. The whole result of running this parse code view, the end result is I change the title and I change the output. Okay, and that, given the packet, I've accumulated the tunes and the measure transform. That's the information I need to do my job, and I do it. All right. Now I want to make a new transform. Source.transform. Source was passed in. Okay, let's deal with the. Oh, the other thing I want to do is this sync and source thing. Let's do that. That's easy, and it'll clear my mind a little. Let's see, to dos. Make input, do the parsing call. Let's do it. Well, we haven't done that yet. Okay. What we did do was we attempt to make a consistent pipeline type system in the playground, but we failed. All right. We make transform be packet to packet, make packet a struct with a helper initializer. And those three things we've done so far. Let's keep track of that down here. Episode 40. Wow. November 30th, last day of the month. And this was Pipeline Playground. Okay, we did these things. This is all pipeline stuff. I'm going to call this pipeline. Okay, so the next thing I want to do is make color, let's see, make background color derived from the transformation type. And this is, it's like an informational. I don't think it affects anything. But let's see. So I guess it's the transforms that need to know it. So let's go back to transform. What I think he needs to have is something that's a transformation type. So let's I think at this point I'm just doing setters and getters. I'm not gonna worry about it. Transformation type, and this is where my source sync is last. Let's call this one transformation, and this is a report. I think it's useful enough to break that distinction out. Okay, and then we want to say everybody's going to know their transformation type. They're all going to have a getter for it. Okay, and that should break some people since nobody knows their transformation type. Parsons code report is a it's a report. Input equals packet. We don't really need that stuff anymore. Okay, but we do need this. Transformation type. Quantizer is a transform. And I might be able to leave that off since we know the type. No. Okay. I guess I'm promising. Ooh, what's the matter? A known case transformation is not a member of transformation type. That looks like somebody's sleeping a little bit here. Okay. Let's take this line. Quantizer, transform, text input source. Again, we don't need these. Binding var input seems wrong. And he's a source. And the output. He's a sync. All right. And where's my Parsons code report view? Sync is not a member. That seems like incorrect. There's no initializers. Oh, this is equals. Try that again. Where's quantizer? Did you right? Okay. And Parsons code report transform. Why aren't you complaining? Oh, there you go. Okay. Report. Okay. Everybody should run. Okay. Now, who references this? Well, that's not really right. Let's see, transform. I guess we can try and pull it from here. Find usages. Okay, that's the view. That's source. Oh, wait a minute. Oh, that's transform. Okay, who uses name? I probably could just search for icon name. Yes, the views do. Okay. So top line. So really what I want is a map from transformation type to color. And I'm not sure where that belongs. It's clearly a UI concern. These all look pretty focused. This is a transformation type to color. And I think I'm just going to make a bare declaration. Let's make an extension. This is on transformation type. And we're going to say color. Returns a color. And we're going to switch on self case dot source case dot transform case dot report case dot sync. Okay. Return, and then Parsons code view report is this. Oh, wait a minute. Shouldn't that be report.color? Let's go look at our assets. Source sync analysis. Oh, yeah, reports and analysis. Okay, whoops. Analysis.color. Source, transformation, analysis, and sync. Analysis, sync, source, transformation. Okay. And it looks like we want the contrast too. So maybe we need to, well, let's just give it a contrast. Now, you know what? Okay. Let's use it. Okay. I'm jumping ahead. I don't think I'm on my to-do list, am I? May go. Okay. That's okay. Source file should be transformation. Okay. Oops, transform. Okay, before I make that better. All right, who's complaining? Cannot find color. All right, nobody's using this function yet. So let's use it in, well, I guess the view? Okay. Let's compare this. What's... I was having trouble getting rid of it at one point. I'll have a compare here. Parsco view, yeah. Okay, pipeline analysis.color. And there's contrast. We need to get that in there too, but this should just work. Okay, the colors are all okay. Let's define the contrast colors as well. Transform, no, it's transformation color. Yeah. Okay, I'm going to make a little helper for this. Let equal okay, I just want to get from source to source. And I don't know, there may be a better way to do this too. Just take the text. Okay. His type is transformation type to string. Okay, source goes to source. You're not really going to make me spell that out, are you? Okay. Transformation goes to transformation. Report goes to analysis. And sync goes to sync. Okay, that makes me want to rename this to analysis. Okay. All right, so now I can just use the map. I can say return color of pipeline slash and then the map dot color. And this is transform to string of self. Right. Analysis, well, he does now. Okay, and this stuff goes away. Transformation type is no member analysis. All right, let's clean up. I gotta stop this view. Transform to string. Oh, that really should be in there. Okay. Should be working the same. Oh, well. It won't affect any tests, I don't think. Okay. And the run should find out. We also know we need contrast. We can take the word return out since Swift just defaults it. And let's make contrast. Same deal. I think the real way would be to rename these things so that they conform to the pattern and then just get the string from the whatchamacallit. All right. So foreground color. Oh, turn that off. Just escape. I got stuck in this mode once before and I couldn't get it to shut up. Where's the parsons code? Okay, I think we're done with that for now. Text parsons code view, that's the one. Okay, foreground color, we wanted the contrast there, so that's source.transformation type.contrast. Foreground color there. Foreground color there. The rectangle gets the color. This one gets the contrast. Okay, that makes sense. And that should all work. Oh. Again, I don't see any tests that care, but okay, colors are good. All right, let's take that one. Make color map for transformation type. Use it in Parsons code view. All right, and then our other views, well, we got text input source. We need text input view. Okay. So foreground color is source. So this is source dot transformation type dot color. And that's the same thing dot contrast. Oh, that's color. Okay. Color. And this one's contrast. And this is just a view color, so we'll run it directly. All right, and this is the same colors inside. Good. Good enough, I guess. Okay. I think we'll bundle a couple in here. Quantize view. Okay. This is source.transformation type.color. And black we're forcing. Okay, it's a touch weird, but okay, quantizer, text input, and text output. Okay. Make sure everybody looks good still, but okay. So the reason I'm doing this is as we create new stages, they need their own little bubble visible, and they need to define what the color of it is. So I think this will do the right thing. Okay, and yeah, okay. So make all output views choose color based on transformation type in transform. Okay. All right. Let's see. So I'm going to close just about everybody. Let's keep Parsons code view. We don't need that one. Okay, how are we doing? Make background and how about derive foreground and background color from the transformation type. Good. I don't know, it's a little easy work for a while. Okay, make 10 source call it's well, this is transform. Let generate report call its transform. Okay, yeah, that seems like a reasonable starting point. We're in this view do it method, and we got the starting packet. I would like to ask the text input transform to do this work here. Create the parser, find the tunes, find the errors. That seems like its job. Okay. So what I'm doing is I'm creating each of those, and then we're going to drive them into an array and then work through our array and then pull stuff out. Okay. Do we have a text input transform? We must, right? Because transform. Well, how do you, what's its source? Content view. Okay, quantizer. Oh, we don't, in fact, have one. Quantizer transform. Text output equals text output sync. I guess that's a transform. All right. Let me add the to-do. Let's take out this notion of sync and source. It's in our transformation type, but I don't think it has any other purpose. Delete sync and source types. Okay. There may be some world where it's better to have those, but I think for us it's not going to be there. Oh, type associated type protocols. I'm going to put that down here with the comment around the playground. Okay. Text input source to the parsing let generate report calls transform. Okay. So in the content view, we see there is no text input transform. So let's do that. Private var text input equals text input source. Oh, I do have that. Let's go there. He's a source. Okay, he's good. He's got this. He's got a init. Okay, so we need to give it the binding to the input. Dollar input. Blah. Okay. His type is text input source. We have to do it in the init. I don't think we need to change those. So I'm just going to create an empty one, init. And then I've got to do it in defer because I can't do it until everybody's ready. And I'll do text input equals text input source of dollar input. Okay, so it wants the string we're going to bind to, but who's not defined? Oh, I guess I can do this. I promised to do it. Okay, yeah. So when you're going to use defer to initialize things, you end up using this bang that says it could be nil, but I promise I will not let it be nil when it counts. And I'm doing that by putting it into defer. Okay, so let's see. So that thing is around. And do we pass it in? Source, okay, this can become our text input. And let's run that. Make sure he's picking up the input from where he's supposed to. Okay, X1, error. Okay, yeah. All right, now the text input view. Let's see. No, I think we want his outside of being installed on a view. This will not update. Outside of being installed. State. Capital state. That's this state, I guess. Access outside of being installed on a view. I'm going to defer that for now. It seems like I can't do it in the body. Constant body initial value will not update. I think that's okay. I'm not changing the thing I'm ever pointing to. It's a one-time deal. And we just saw it work, so we may look that up at some point, but I think I really want to get text input source in some kind of shape here. What's going on here? Okay. Yes, his transform, what he should do is take his input. He should do the stuff in here, this stuff. Okay. So text input source, we got the packet. Well, we're going to do that. We're going to return packet with whatever our original packet was. The tunes is tunes, and the errors is parser.errors. Okay. Okay, so text input source, it doesn't look at anything on the original packet, but it replaces tunes and it replaces errors. Okay, and that is what we want. Now, this, how do we get access? Okay, content view does not know the text input. I'm sorry, content view knows text input, but Parsons code view does not. I think we can let it create one for a moment. If we said let text input equal text input view with $input, text input source with $input. So I'm going to create our own, basically. And then I'm going to say, let's make this a var. I'm going to say packet equals text input dot transform of packet. And then these things go away. Cannot find tunes. Oh, we don't need tunes because they're already in the packet. All right, this should run. I'm creating redundant text input sources off that thing to do the transforms. That's a little weird, and we're going to have to work at that out at some point. But X1 T test, key of F and FED. Okay. Everybody, well, this thing clearly passed along its stuff, and we'll put an error in. Just to make sure the error report comes through as well. It does not. Okay. Oh. Errors. Errors is empty. Let's run this again. Maybe we're seeing this error. X1 key E. No errors. Not there. Loading. Errors. Let's see the input. Well, it has no input. Okay, let's print input. Okay, the input looks legit. It certainly should have an error. Did I not put them in? I thought I did. Transform puts parser.errors. Okay, let's... Well, I guess I'm going to stop there and see the errors. Why is errors empty? Okay, packet equals transform of packet. All right, packet shows no errors going in. All right, let's continue. We do fine tunes. Let's step over. Let's see the errors. Well, there's an error coming out. Parser.errors is not empty. All right, let's go out. Maybe I just didn't go far enough. Yeah, I didn't go far enough. Okay. Now errors. Packet errors has them. Okay. And then when they go in here, let's run to here. Nil. Okay. Why packet? Oh, it is nil. Yes. Okay. But p self.errors. No, p packet.errors. Should have one in it. Okay. Yeah. Let's go out of here and in again. Okay, and let's look at packet. Better have some errors. Okay, good. Packet with title and output. Port. Okay, let's step in here. Packet has errors, so he's going to take. Okay. Let's break in here. Continue. Is nil and packet dot errors is that. Okay. Step out. Parsons code report transform should have errors in its result. Oh, we didn't capture the errors as an output. Yeah. Okay, so the output things, that's unfortunate. Packet. So some of these attributes are inputs, and some of these are outputs. The outputs need to be reflected in the thing. Okay. Well, anyway, this should work now. Before we were putting it in packet and looking at packet, I think. So we'll mix it up. That probably is enough to generate a problem. And continue. Okay, errors found. Good. All right. We are. Okay. Text input. Okay, so now text input source does its work, and other Parsons code view uses it. Text input source does its transformation to do the parse, and Parsons code view calls it. Okay, we're going to have to figure out that one at some point. I think once we get everybody owning the right place, then it should be fine. Okay. Let's take this out. Now, should quantize. Where's the quantizer transform? Text input source. Transform. Is anybody using this? I think the only use is to get those name and colors. Okay, content view creates one. Settings view, quantizer setting view knows it. Okay. And transform. Okay. Yeah. So again, this thing needs input from its view, and maybe I'm getting at that the wrong way. So we'll pick up there. Okay, text input source to the parsing. make quantizer transform apply its rules to the packet and call it. Okay. And figure out the sync text output sync and where it gets info. Okay, delete sync and source types. You know, I think I can do that right now. Text output sync. Okay, that is going to become a transform. Sync this text output view can just be a transform. Type alias sync and source. Let's take them both. Okay, a build should tell me who's calling them. Okay, source is a transform. Text input view is a transform. All right. Run tests. Whoops. Okay, delete source and sync types. All right. All right, so I think we'll continue tomorrow. We're going to push on building the pieces of the pipeline, get the quantizer done, get the text output done, and then work on pulling them up into, I think it's in content view maybe, that needs to own the whole set of them, and we'll figure out how to bind stuff into them there. I think this warning is probably means something. I mean, it's a nice red warning. So we'll take care of that. Next time is tomorrow, Thursday, December 1st. It's 1 to 3:30 p.m. Eastern Standard Time or 6 to 8:30 p.m. UTC. Thanks for joining today. Hope I catch you in the future. Take care. Bye-bye.